In today's lecture at Medical Sciences, we want to look at percent solutions. Then we are going to look at how we calculate normality of solutions. Then we shall end up with the conversions of units, either from grams percent or when you're given milligrams to millimoles per liter. And as we begin, we remind you to subscribe if you haven't. Make sure to like the video and share to many others. So, I want to begin by looking at percent solutions. Percent means 100. So, percent solutions, these are solutions made whereby the total volume or the total amount is equal to 100. And these percent solutions whereby the total amount is equal to 100%, they can either be weight by volume, and weight by volume is the most commonly used. Weight by volume. In laboratories, this is the most common way of preparing reagents, preparing solutions, whereby we have grams dissolved in mils of either water or any solvent. So that is weight by volume. For example, I can say 10% sodium chloride solution, it contains 10 grams of sodium chloride dissolved in 100 mils. That is what 10% means. 10% means 10 grams dissolved in 100 mils, or what you can call a deciliter, because 100 mils is equivalent to a deciliter. So that is what 10% means. If someone says 20% weight by volume, maybe hydrochloric acid, this one means 10 grams of hydrochloric acid dissolved in 100 mils of the solvent or the distilled water. So that is weight by volume. Then another second one we look at under percent solutions is what we call weight by weight. Weight by weight. And under weight by weight, here you get grams of the solute. You dissolve it in grams of the solvent. That is what we call weight by weight, and this is not commonly used. So this one, you find maybe the solute is maybe 10 grams, which is dissolved maybe in 90 grams of the solvent. So this is what we mean weight by weight. So under weight by weight, we don't care if the volume exceeds 100, so long as when we add the weight, it should give us 100, which is different from weight by volume. For weight by volume, the total amount of solvent, the volume should be exactly 100. But for this, the volume can exceed 100, but the weight or the grams should be exactly 100. That's why it is not commonly used. The commonly used one is weight by volume. Then lastly, we have also volume by volume. Volume by volume, whereby this is also a way of measure, whereby you get maybe like 30 mils. So this one is liquid to liquid. When you are mixing liquid together with liquid, you use volume by volume, volume per volume. whereby you can have maybe 300 mils of hydrochloric acid, then you add it to 70 mils of D water. So this one is used when all the solutions you want to mix or to prepare are all in liquid form. So you can measure them in volume by volume. So these are percent solutions, whereby under percent solutions, the most commonly used is weight per volume, but we can have also seen that we can use weight by weight if all of them are solids and can be measured or weighed, and also we can use volume per volume if all are in liquid state. So after understanding this, we are now going to go to another second part of our discussion today, whereby we want to discuss normality. Normality is also used to measure concentration of substances in a solution, but the most accurate one is molarity. Molarity has replaced normality because normality does not give accurate results to measure the concentration of solutes in a solution. But normality, by definition, this is the number of equivalent weight. Number of equivalent weight. Equivalent weight in grams. This equivalent weight should be in grams. Equivalent weight in grams of a solute in per liter of a solution. In per liter of a solution. So this is what we can define the term normality, meaning normality by formula. You can get it by saying normality is equal to number of equivalent weight, number of equivalent weight in grams, then you divide by number of liter in a solution. That is what we can use the formula. Then another formula, we know that equivalent weight is the same as, we can tell you that equivalent weight is equal to molecular weight, is the same as molecular weight or molecular mass is equal to molecular mass or molecular weight. You divide by valence, whereby valence is the combining power of an element. So if you get the molecular mass or molecular weight of a solution or a substance, you divide it by valence, you are able to get the equivalent weight, which is defined as normality, because we have seen normality is the number of equivalent weights. And equivalent weights, to get them, you get the molecular mass of a substance, you divide by valence. Then the third formula, because the first formula we have seen, normality is equal to number of equivalent weight in grams divided by volume in liters of a solution. Then still we have seen that equivalent weight here, to get it, you have to get the molecular weight of a substance, you divide by the valence. Then lastly, in terms, if you want to convert molarity to normality, you are going to say that normality is equal to, normality is the same as molarity, whereby we say the molarity is the same as mole per liter times valence. So when you use this formula, can also give you, in case you are given molarity and they want you to convert it to normality, you can easily use this formula, that normality is equal to molarity times valence. So this formula can be used. For example, here we can use an example here. that maybe you are provided with 2 molar sulfuric acid, then they ask you to calculate the normality. So to get the normality of this acid, we shall say normality is equal to molarity, which is 2 molar times the valence. And the combining power of sulfuric acid is 2. And then our normality of sulfuric acid will be 4 norm sulfuric acid. Then if you are given, maybe they tell you that we have 2 molar HCl and they ask you to calculate the normality, you get this one still times the variance. So the normality of HCl is equal to 2 molar times the variance of hydrochloric acid, which is 1, and the answer becomes 2 norm. So this, what does it mean? For monovalent compounds like hydrochloric acid, which have a valence of 1, normality is the same as molarity. I want you to note that. For monovalent compounds, compounds with the combining power of 1 or with the valence of 1, normality is the same as molarity. Whereas for divalent compounds or compounds with a valence of 2, we're going to say that molarity is half normality, or we can say that normality is equal to it doubles the molarity. So that's why we end up saying that for divalent compounds, normality is half molarity. So to get normality for compounds with a valence of 2, you get the normality, you divide by 2. That is what I'm meaning. But for monovalent, for it, normality is the same as molarity. And we can go ahead and also do this calculation, which is given that how many grams of sodium carbonate are required to prepare 1 liter of 1 normal sodium carbonate. So here we want to see how many grams we need to prepare 1 liter of 1 normality sodium carbonate. So we have the sodium carbonate. So the first thing we are going to do is to calculate the equivalent weight, whereby the equivalent weight we are calculating A, whereby equivalent weight of sodium carbonate is equal to molecular mass, you divide by valence, and the molecular mass of sodium carbonate, to get the molecular mass of sodium carbonate, sodium is 23. We are given that the atomic mass of sodium is 23, but sodium are 2, you multiply by 2, then you get the sum of carbon. Carbon is 12, as given here in brackets. Then oxygen is 16 times 3, and the total you get 106 grams. So the molecular weight of sodium carbonate is 106 grams. So to calculate its equivalent weight, therefore the equivalent weight of sodium carbonate is equal to molecular mass, which is 106 grams, you divide by valence. And the valence is 2. The combining power of sodium carbonate, we are seeing it is 2. And we get grams, we get 53 grams. So these are the grams that we shall need. So For 1 liter, these ones are in 1 liter. These ones are in a liter of a solution. So we are going to end up by saying that to prepare 1 normal sodium carbonate is the same as you have to get 53 grams of sodium carbonate powder. You dissolve them in 1 liter of distilled water. And this is what they wanted. So the grams, we shall need 53 in a liter. So if it was more than 1, we would have multiplied either by 2, the way we are going to see under this example, whereby this is example B, whereby under example B, we are required to calculate how many grams of sodium. For here we are using sodium hydroxide. We want how many grams are required to prepare 5 mils of 2 normal sodium hydroxide. So the first thing we are going to do is to calculate the molecular weight of sodium, the molecular mass of sodium hydroxide, which is equal to sodium, the atomic mass is 23, as given here, plus oxygen, which is 16, plus hydrogen, which is 1. Hydrogen has the atomic number of 1. Then the total is going to be 40. So the molecular weight of sodium is 40. Molecular weight is the sum of the atomic mass of different elements within that compound. So after getting the molecular mass of sodium hydroxide, so the equivalent weight of this substance is going to be 40 molecular mass, which is 40. Remember, equivalent weight is equal to molecular mass of that compound divided by valence, which is equal to 40 grams. And the valence of sodium hydroxide is 1. So the equivalent weight will remain 40 grams. After getting that, we have seen in this first formula that the normality is equal to number of equivalent weight you divide by number of liters. So, and we are given a normality, which is 2. So we can use this formula to come up with the number, whereby we can put it this side, whereby from normality equaling to number of equivalent weights, divided by number of liters. And our normality is given as 2 normal. So where there is normality, we are going to substitute. So 2 normal is equal to number of equivalent weight. How many are they? They are 40 grams. And we divide it by number of liters. And this one might not bring it well. We can approach it in this way. That after getting these ones are in a liter. These 40 grams which we have got here of sodium hydroxide, they are dissolved in a liter. So these are the same as these ones are covered in 1. So 1 normality of sodium hydroxide is having 40 grams. And these 40 grams are dissolved in 1 liter. So if these 40 grams are being dissolved in 1 liter, but before we bring the analogy of a liter, if 1 normal of sodium hydroxide is containing 40, what about 2 normal? So we are going to say that 2 normal will contain 40 grams of sodium hydroxide. We multiply by 2, which we shall get 80 grams. And these 80 grams are in 1 liter, are still in 1 liter of the solution. So to prepare 2 normal sodium hydroxide, we need 80 grams. We need 80 grams to prepare 2 normal sodium hydroxide, which is dissolved in 1 liter. So if 1 liter dissolves 80 grams of sodium hydroxide to form 2 normal sodium hydroxide, what about 5? What about 5 liters? 5 liters will need to dissolve 5 times 80 divided by 1, and we shall get 5 times 8, that is 40. So we shall get a total of 400 grams of sodium hydroxide. So how many grams shall we need to prepare 5 liters of 2 normal? We shall need 400 grams of sodium hydroxide. That is what we can say. Because we have seen that 40 grams prepare 1 normal sodium hydroxide. Then what about 2 normal? You get 40 times 2, which is 80 grams. And these 80 grams are always in per liter. Remember the definition of normality. Number of equivalent weights per liter of a solution. So whenever you get those equivalent weights, they are dissolved in a liter. So that's why we are saying these 80 are in 1 liter. So what about 5 liters? That's where we get 5 times 80. So here we cross multiply, we get 5 times 80 divided by 1, and we get 400 grams of sodium hydroxide are the one that we shall require. So in the procedure, we shall weigh 400 grams of sodium hydroxide powder. Then we shall dissolve them in 5 liters of distilled water. And that one shall be able to have prepared this solution. So this is how we can discuss today under normality. Please note these 3 equations. That equivalent weight of a substance is the same as molecular mass divided by valence. And in case you're given molarity, normality is the same as molarity. You multiply by the valency of that compound. If you can master these 2 equations, then you can be able to attack each and every calculation. And I want you also to remember that whenever you get equivalent weights of a substance, these equivalent weights are in 1 liter. So in case they need more than 1 liter, then you have to multiply that number by the liters which you want to prepare, because the equivalents you will get, they are in 1. That's why the definition says equivalent weight in grams of a solute per liter of a solution. So that is what I wanted you to note. So let us go to subsection C of this discussion. Here we are going to look at the conversions of units in this last part of this video. And we want to see how can we convert milligrams to millimoles. If I'm given a figure in milligrams and I'm told to convert it in millimoles, how do I use, which formula do I use to calculate? And we are going to see that millimole, if I have millimole per liter, is the same as milligrams per deciliter, and per deciliter can be, it is the same as per 100 mils, because 1 deciliter is equivalent to 100 mils. So you get milligrams per deciliter times 10, then you divide by the molecular weight. or molecular mass of a substance divided by the molecular weight or molecular mass of that substance. So this is the formula we can use. Milligrams per deciliter times 10 divided by the molecular weight or molecular mass of that substance. And this is the formula we use to convert millimoles per liter to milligrams per deciliter. For example, here if I'm given to convert 180 milligrams per deciliter of glucose to millimoles per liter, the first thing I need is to calculate the molecular weight of glucose. And the molecular weight of glucose, whereby glucose is C6H12 or 6, and carbon is from here, carbon is, the atomic number of carbon is 12, so I will get 12 times 6 plus hydrogen atomic mass is 1 times 12, then plus oxygen is 16 times 6, and the total molecular weight is 180 grams. So the molecular weight of glucose is 180 grams. So after getting the molecular weight, to get millimoles per liter of glucose, I'm going to substitute in the formula milligrams, which is 180, milligrams per deciliter, which is 180 times 10. Then I divide by the molecular weight, which is 180. The milligrams per deciliter is 180, and also the molecular mass is 180. So at the end, we are going to shall get this divided by 180. This 0 shall go with this, and by 18.1, we remain with 10 millimole per liter of glucose. So this one becomes the answer. So we can say, therefore, 180 milligrams per deciliter of glucose is the same as 10 millimoles per liter of glucose. So this one becomes the final answer. So this is the formula. Millimoles per liter is equal to milligrams per deciliter times 10 divided by molecular weight. So the major thing is to calculate the molecular weight of that compound, and the atomic mass of different elements in a compound are always given in the question. So always check them out in the question. So we can here we can answer part B, whereby part B, they require us to convert 40 milligrams of sodium hydroxide. And to convert 40 milligrams per deciliter sodium hydroxide, we have to first calculate the molecular mass of sodium hydroxide, whereby sodium, the sodium is 23, plus oxygen, which is 16, plus hydrogen, which is 1, and I get 40 grams. This one becomes the molecular mass of sodium. And if I have the molecular mass of sodium, millimole per liter of sodium is the same as the number in milligrams per deciliter, which is 40 milligrams per deciliter times 10. Then we divide by 40 grams. This 10 is converting milligrams to grams. Milligrams per deciliter to grams per liter. So at the end, we shall get 40 going with 4. This 0 can go with this by 4, 1. That is, we end up getting also 10 millimole per liter. This one becomes the final answer. So this is how we can convert milligrams per deciliter to millimoles. So long as I can know the molecular mass of the substance, I can easily convert it to millimoles per liter. And even vice versa, if I'm given this, I can also convert it back by still using the same formula, whereby I come and substitute. But we shall see in the coming video, we shall also see how we convert milligrams per deciliter to millimoles per liter and vice versa using first principles. So make sure when that video is out, you check it out so that you can even learn how to do them from first principles without using the formula. That is what we shall see. Lastly, we are going to see how do we convert grams per cent weight by volume to moles per liter. That is the last part we want to see. And whenever you're given to convert grams per cent to mole per liter, is the same as grams per cent in weight by volume. You multiply by 10, then you divide by the molecular weight, divide by the molecular mass or molecular weight. Of that substance. That is how we can convert. So if I'm given an example that converts 4% weight by volume, 4% means 4 grams dissolved in 100 mils. That is what this one means. 4 grams of sodium hydroxide dissolved in 100 mils of distilled water. That is what we mean. So to convert this, the first thing is still to calculate the molecular weight of sodium, and the molecular weight of sodium, we have already calculated it here. It is 40 of sodium hydroxide is the same as 23 plus 16 plus 1, which is equal to 40 grams. And after getting these 40 grams, so moles per liter or molarity is equal to grams, which is 4 grams times 10, because I told you 4% means 4 grams dissolved in 100 mils. Then we divide by the molecular mass, and the final answer shall be 40 divided by 40. And 40 divided by 40, you end up getting 1. So, in conclusion, 4% weight by volume of sodium hydroxide is the same as 1 mole per liter. Is the same as 1 mole per liter. That is what we can see. So, then in your free time, you can also convert this. You can convert this. You can easily convert this 0.9 weight by volume of sodium hydroxide to moles per liter, whereby I told you that percent means grams dissolved in 100. So this means it is 0.9 grams of sodium chloride dissolved in 100 mils of distilled water. This is what it means. So the next thing is to look for the molecular mass of sodium chloride, whereby sodium is 23 and this chlorine is 35.5, which is 58.5 grams, the total. This is the molecular weight. So to get the mole per liter is equal to grams, which is 0.9 grams times 10, then you divide by the molecular weight, 58.5. Then you end up getting 9 divided by 58.5. And if you get 9 you divide it by 58.5, you are able to get the answer, which is in 0 point something. So you can get here the final answer when you have the calculator. You can easily get the final answer. So this is how we can go about these calculations, whereby in this video we have looked at percent solutions, we have looked at the normality and different formulas we can use. We have looked at how we can convert milligrams per deciliter to millimoles per liter, and we have given different examples, and we have ended up to look at how can we convert grams per cent to moles per liter, which we call molarity. Thank you so much for learning with us from beginning until the end. Be blessed.